Here, considering this graph of G, we have no formula, just a graph. And if I want to state the domain and the range of G, okay, so the domain of G, that's all the x values that this function lives on. So the furthest x value looks like -3, and that's the furthest to the left, and the furthest to the right looks like +3. So my domain is going to be -3 to +3. And then the range is a set of all y values that the function lives on, the smallest of which looks like -4, and the biggest looks like 1. So this will be -4 to 1. All right, now to evaluate g of -2, -2 is in parentheses there. That means it's an input or an x value, and this is asking me for the y value. So I find the x value of -2. I go up to the graph and read off the y value. So g of -2 is 1. I want to find the x values where the output is -2, where the y value is -2. I find -2 on the y-axis, and I need to find all the x values that give me that y value. So it looks like I have one at -3, one at -0.5, and one at 2. -3, 1/2, and 2. Each of those x values give a y value of -2. On what intervals is g decreasing? So you always read a graph from left to right when you're talking about increasing, decreasing. So if I start at the very leftmost point, I have increasing, then I have decreasing, decreasing, and then increasing again. So this function is decreasing starting right here, and we only ever give the x coordinate. So it starts at -2, and it stops at 0. Those are the x coordinates where that function is decreasing. And for increasing and decreasing, we don't include the endpoints, because at -2 and at 0, this function is really doing neither. It's switching from increasing to decreasing or decreasing to increasing. Give the values and locations of local minimums of g. Okay, so local minimum is a low point. So I've got one right here that happens at 0, x coordinate of 0. There's a minimum value of -4. One little mistake here, that should be -0.5, places where g of x equals -2.